Lecture 7 is about three very important concepts, right? This is essentially the, kind of the entire content of Markov chain theory, especially as it relates to the stationary distribution, which we've already kind of motivated really well, hopefully really well. Certainly seen it in this Google PageRank application, right, where hopefully this convinces you that it's really an important topic, and if you do work with Markov chains, it'll come up time and time again. So when working with stationary distributions, you really have to get a handle on three concepts of maybe increasing level of difficulty. And maybe you've seen these in 160A, but we're really going to try to go for a very kind of brief and maybe condensed, but also rigorous treatment. So irreducibility is perhaps the easiest one of all. And so so Ross does a decent job on it, but I feel like there are way too many definitions, which is what usually happens in these books. They mention all these accessible states communicating with one another. It's just a lot of jargon that I feel like is not needed. So I'll try to give you my own kind of version of it's not any different, but my own take on irreducibility and what's really important in understanding that concept. Periodicity is not covered well in Ross. It doesn't actually give a very precise definition, so we'll spend a little bit of time on that. Periodicity is essentially this one property that prevents limits of k-step Markov chain transition probabilities from converging to the stationary distribution. So this is an important aspect to understand, but only kind of in terms of maybe one specific application. So by far the most important concept is the concept of recurrence, which comes packed with these other notions of transience, null and positive recurrence, and so on. And so after this we'll be in position to really kind of look at some very useful theorems, and unfortunately I find that again, books don't kind of summarize these results well, so I'm going to post a note for you. This is my take on kind of the most condensed summary of results that you should really be aware of, and so at this point you don't need to necessarily spend time unpacking this, but by the end of this lecture you should be able to read this, right? This is the second page of the note, and really kind of understand all these results and how they interrelate in their connection to the stationary distribution, right? In particular, right, we'll look at when the stationary distribution fails to exist, right, in theorem 2.4 here. So, and with that said, let's move on to irreducibility.